Thanks for joining our e-seminar about Tosca Structure 8.0.1, and let's start. So some words about our agenda. We will start with a short introduction to Tosca Structure now within Simulia, and afterwards we will introduce the new optimization method Tosca Structure sizing, which is a brand new optimization module within Tosca. Afterwards, the second new, the so-called new advanced capability, which is called Tosca Structure Morph. And then we will focus on the new optimization module within Abacus CAE, offering to all the Abacus customers a brand new optimization authoring interface within the Abacus CAE. And we will spend some time to further enhancements on graphical user interfaces. And in the end, as Gregor already mentioned, we'll have a Q&A session. So Simulia Tosca Structure, it really delivers powerful optimization solutions for design of lightweight, stiff and durable parts and assemblies within shorter development times. So the simulation-based optimization is really all about reducing costs and development time. So in a conventional design development process, you usually design your product, build it and test it. If you're relying on simulation, you will design and analyze it at first and then build and test it. If you're introducing the simulation-based optimization into your design development process, you will optimize already in the beginning, have a better and optimized design earlier in your development phase, and build and validate it only afterwards. So you really reduce the development time and decrease the cost of the whole product development. Simulia Tosca Structure is an open solution. That means that we are integrating seamlessly into any existing CAE environment. In a traditional CAE environment, we have a CAD system on the left. We're using certain CAE pre-processing tools to create simulation and FEA setups and solve it, for example, with Abacus, ANSYS or MSc Nastran. And afterwards, we have some CAE post-processing tools, and finally go back to a CAD system. If we're now introducing Tosca Structure into this existing CAE environment, it will automatically couple itself with Abacus, ANSYS or MSc Nastran FEA solvers and only offers a certain interactive optimization authoring tools, for example, the new optimization module in Abacus CAE, the well-known Tosca Answer environment, the Tosca extension for ANSYS Workbench, or our Tosca Structure GUI. And all the other part of the CAE environment can be kept as it is, so it's in really putting in Tosca and it's working with the whole existing CAE environment. So Simulia Tosca Structure consists of 4 optimization modules, 4 different optimization methods, so to say. At first we have Tosca Structure topology. The topology optimization is intended for early phases of the design development, finding the design with maximum stiffness or minimum weight, for example. As a second method, we have the sizing module, which we will introduce afterwards, which is brand new, released with Tosca Structure 8.0, and it's all about reducing mass through optimized sheet thicknesses. For a later stage of the design development, we have the shape optimization capabilities. It's really slightly changing the design to reduce local stresses and to increase the durability. And our fourth module, the bead optimization, it's adding or finding the perfect bead layout for a certain structure to increase the stiffness or the eigenfrequencies of sheet metal structures. As Tosca Structure is now being part of the Simulia portfolio, Tosca Structure is licensed via extended tokens. So-called Simulia extended tokens are a very flexible licensing system. So we have one token type which enables most Simulia products. So already now, having extended tokens, you are able to run Abacus Standard, Abacus Explicit, Abacus CFD, as well as the parametric optimization solution iSight, and now also Tosca Structure. There will come for sure more products to be within extended token licensing. For example, in summer there will be Tosca Fluid also available via extended tokens. As a short rule of thumb, most common Tosca Structure optimization tasks need in an Abacus Standard FEA environment 8 extended tokens. If you plan to use it with ANSYS or MST Nastran, you need 1 additional token. This extended token licensing is for optimization technology itself. For graphical user interfaces, separate licensing may be needed. So now we really want to focus on the brand new optimization capabilities introduced with Tosca Structure 8.0. And I'd like to hand over to Gary.
Yes, hello everybody. Let me go on and go a little bit more deep into our new module. So as you probably know, so far Tosca Structure offered 3 modules: topology, shape and beat, and all of them allows you to change the design of your product in a different way. So the new module, Tosca Structure Sizing, allows you to redesign complex sheet metal structures by altering the thickness of its components. And doing so, you're able to improve the static and dynamic behavior of these products, such kind of products, really by only modifying the thickness of such structures. So the challenge that is probably most common in many industries like transportation and mobility, aerospace, defense, industrial equipment, wind energy, it's the weight. The weight, of course, influences directly the costs as you try to save material in your product, but it also influences the comfort and safety. It's important also for the performance and the eco-efficiency. It's not only about saving the money by reducing material and less iterations in the design development, but it's also the regulations that are becoming even more and more important about the eco-efficiency, for example, CO2 emissions reductions and so on. So it's really important to be able to balance the lightweight designs and on the other hand to keep the performance of your products. And optimizing the structure to guarantee the best overall performance is what the real challenge is. So in this case, when you have structures mainly consisting of sheet metals, Tosca provides a new solution, Tosca Structure Sizing, with which you can optimize with respect to static and dynamic behavior. This solution is feasible for a large scale of application, complicated, complex ones consisting of many different sections and up to millions of design variables. You are able to apply manufacturing constraints, and you could also cluster the elements into groups and yourself define which areas should have the same thickness. Going more into details, since the shell structures, the thin structures are defined and modeled with the shell elements, what Tosca does, it takes the thickness of each element as a design variable. You can, of course, set a lower and upper bounds, we support the most typical shell elements that are used in such kind of models and handle them all as separate design variables. So basically you are able to optimize over millions of design variables. You can use two principally similar approaches, but they lead to a very different results and are applied at the different stages. For example, you can consider the elements individually. So you have the flexibility of exploring many different designs. This gives you the opportunity to make decisions at the early stage where you are still allowed and still have the possibility of going back to a CAD designer and redesign maybe a structure. Or you can cluster elements into certain sections by imposing that they have the same thickness. So probably this would be a solution that you would use in a later stage to ensure that your design is very near to the manufacturable final design. Now the good thing here, the absolutely fascinating stuff, is that you can use these both approaches independent of the fact that in one case you have relatively less design variables, maybe 10 or 100, and in the other you have millions. Still you don't have much more computational effort. This is because we are using the sensitivity method with the joint computing the joint sensitivities, and this do not bring more computational efforts in the method. The optimization formulations are, as you know, with the topology optimizations, we have a big freedom. Of course, you can optimize on the mass or use it as a constraint. We have different measures for static loads, either a global one using a compliance or, for example, displacements at a certain nodes. You can consider forces, internal or reaction forces, also the momentum. You can consider modal eigenfrequency load cases, or also vibroacoustic measures. You can apply manufacturing constraints, as I mentioned. This includes not only the minimum and the maximum thickness, but also different symmetries, which may be required for your application. So you have a very large number of responses that you can consider. At this point, however, you cannot consider the stresses within the Tosca structure sizing. On the FE modeling side, we can use the single layered shells. You can have in your model a constant temperature loading. Contacts are also supported, also within the area where you have a design element. Outside of the design area, we support all kind of non-linear modeling. Within the design area, however, only non-linear materials are supported, and the geometrical non-linearities at this stage also not supported. This solution is available for Abacus and for ANSYS as FE solver. So let's have a look at one example. We have a complete body in white here, structure with the initial weight of around 330 kilograms. In this case, 350,000 elements are there in the model. We have taken here the second approach, which means that every section in the model would have its individual thickness, so the elements within one section will have the same thickness, and therefore they are grouped or also clustered. Our optimization task is starting with this design to minimize the mass by keeping a stiffness. So in this case it was a kind of available and almost ready product, but still we want to optimize without bringing in a lot of significant design change. What we have is that only after 15 iterations, it means 15 Abacus runs, we have achieved in reduction of 15% of the weight. And on this side you can see the three constraints on the stiffness. So we have the axial bending and torsional stiffness, Two of them are at the end also maintained, so they did not become worse, and even the torsional one was much more improved. So basically our structure's performance was maintained, but we have saved 15% of mass with only 15 Abacus runs, which are absolutely automatically running without interference from the engineering side. And again, the overview, the summary, that we have saved 50 kilos on this structure and maintained the stiffness automatically. So your benefits using the Tosca structure sizing for shell structures is that you can obtain the optimum combination of weight, stiffness, and dynamic behavior, ensuring also manufacturability, and get material savings while having the increased comfort and eco-efficiency. This product, we believe, will help you to meet the performance goals, reduce your development time. Now let's go and see about a second big enhancement with Tosca 801, and this is the morphing.
Yes, so our morphing is a so-called advanced capability. It's not an optimization module itself. It's enhanced feature which enables for faster design decisions by quickly changing mesh geometry. So it's very nice tool to perform design modifications on an existing model. So what we're doing with our shape morphing approach is that we're simply adding morphing displacements. So we define a node set, define a direction, and a user-defined morphing displacement, and in this case it would result, for example, in such a modified geometry. So we're really moving surface nodes similar to a shape optimization, but the big difference at that point is that we have no optimization driven displacement. It's really user defined. It's kind of a design investigation tool. So the user is defining what to change on the geometry, and it's done by Tosca Structure Morph. The nice thing about this tool is really that manufacturing constraints are possible to consider within these design changes, these manual design changes. So for example, in this case, we like to consider a demold direction. We realize in this modified design, it's not demoldable due to this undercut. If we tell Tosca to use the well-known manufacturing constraints, in this case demolding, it will consider that in the displacement, in adding the morphing displacement, and will create a demoldable design. So besides a demolding manufacturing constraints, we can assure minimum and maximum member sizes. With this morphing approach, we can also handle symmetries, so to say plane, rotational, cyclic, and cyclic plane symmetries. And what is also a nice feature is this morph to surface. So we have a simulation model and we like to move it onto this pipe, and we will get such a surface or contour. It's really done very quickly, and the big advantage of that is it's, on the one hand, it's quick and easy, but we really can perform complex design changes without having to recreate the simulation setup. So we're only modifying certain nodes of the simulation model, so we do not have to remesh, we do not have to reapply loads and boundaries. The whole simulation setup is still valid after the design change, so it really enables CAE engineers doing their own geometry changes without having to rely on the CAD people. So it's way more easier and faster to try out some effects. What happens if I add some material in this area to my overall performance? It's really the purpose of this advanced capability, to explore or to investigate the design in an early phase of the product development. So we really believe it can drive innovation in an overall shortened product development process. And what is also a nice feature within, so you can create automatically a lot of different design variants and send them all in parallel on a HPC environment, and afterwards easily investigate the overall performances or certain performance measures with the post-processing tools of Tosca.
Also, one very nice new enhancement related to the topology optimization. In the classical way, and probably the most common way, Tosca structure topology is used is to consider the stiffness. So one of its measures is the measure for the global stiffness, which traditionally used compliance. However, in the case when there are combined static loading and prescribed displacement, it's not easy to set up the right optimization formulation that will bring you to optimal structure. And let me show what the problem is. If we have a completely force-driven scenario, then the maximum stiffness will be for a design in which the compliance is minimized. And if we have a prescribed displacement, then the maximum stiffness would be for a design where the compliance is maximized. Now, when you have a combined scenario where both situations exist, it's not easy and many times even not possible to define which formulation to be used, and it's not also sure that you will achieve optimal structure by using one of these. So what we did is we introduced a new measure for the stiffness. It's called the energy stiff measure, which combines these two scenarios in a clever mathematical way, and it ensures you that you will always go to a maximized stiffness if you minimize this measure. So your benefit is that you have a unified approach in all scenarios when you have forced or path control problems. It's applicable in all cases, and it's highly recommended that you can now easily use this measure instead of the compliance approach to further optimize the topology of structures with respect to their stiffness. Let's go now to the authoring possibilities with the new version of Tosca.
Yes, as we earlier mentioned, so Tosca Structure is really an open solution working with Abacus, MSc Nastran, and ANSYS as well. So we're also offering a lot of opportunities or possibilities to author your optimization tasks. And so far this has been the Tosca ANSA environment, which is a subset of the ANSA preprocessor, which is widely spread within the automotive industry, and ANSA is actually a product of Better CE systems from Creek, and we're using this Tosca ANSA environment to offer authoring tool to author optimization with Tosca. On the other hand, we have the Tosca extension for ANSYS Workbench, which integrates Tosca topology optimization seamlessly into the ANSYS Workbench environment, and we as well have the Tosca Structure GUI, which is a kind of form-based way to create your optimization setup. As Tosca Structure is now a part of Simulia, we like to introduce with the brand new Abacus release together with the Tosca release the optimization module in Abacus CAE. So it's really a new way to author, run, and post-process Tosca Structure optimization tasks within the already known Abacus CAE interface, and we like to introduce this in more detail now. So the new optimization module within Abacus CAE is really all about the perfect technology fit from what we believe. Tosca Structure really is able to to benefit of all the Abaqus realistic simulation capabilities, of all the nonlinearities, where Abaqus is really strong. So you can really rely on the Abaqus realistic simulation and use this for a realistic optimization with Tosca Structure. So it really makes sense to couple or integrate both much stronger than before. So a short overview about Abaqus CAE. It's the complete Abaqus environment. So it's an integrated graphical user interface for FEA. So far, it enables for FEA authoring, FEA analysis, as well as FEA post-processing. And for that, it offers associative interfaces, for example, to major CAD systems, CATIA, SolidWorks, as well as NX and Pro-E. It offers a mixed modeling approach, which is pretty nice, so you can import orphan meshes, for example, from ANSA or HyperMesh, and create on this your FE analysis. It's possible to author nonlinear FE simulations, as well as a lot of post-processing capabilities, for example, the view cut capability, which is part of the Abaqus CAE interface. Now, with the optimization module, we are extending the Abaqus CAE capabilities from an FEA authoring tool as well to an optimization authoring tool. So based on the FEA authoring, FEA analysis, you can afterwards continue with an optimization authoring directly within the well-known Abaqus CAE interface, one-year optimization, and finally post-process your results, all in one interface. So even it's fully integrated, it's still fully flexible. So on one hand, you can start from scratch. You can start with a CAD geometry, for example, from CATIA or Pro-E, or use existing orphan meshes. But you can as well start with an existing FE analysis, so a full Abaqus simulation setup, and just do the optimization authoring within Abaqus CAE. That's also possible. On the other hand, we are able to run the Abaqus and Tosca Structure jobs on the local machine, or we are able to put them in an HPC environment to run in a parallel environment and be way faster with the calculation times. And we can again, of course, import the existing optimization results. For example, of these HPC jobs, we can import them back to Abaqus CAE, have a look at the results, and export the optimization results back to CAD. So now we really like to go in a little bit in detail about all these functionalities. The optimization authoring is really straightforward in the sense of Abaqus CAE. So the optimization module, which is, for example, this tool chest, which is actually the optimization module, it's really fitting well with all the other CAE modules. It's really straightforward. You can continue with each module, and at a certain point after FE analysis, you will come to the optimization module and start with optimization authoring. So it's really offering now to author topology, sizing, and shape optimizations within Abaqus CAE based on the already known and intuitive usability. And it's really interactively on the 3D Abaqus standard model, so you can pick your element sets, node sets, all this directly on the model within Abaqus CAE. And also what is pretty nice, the whole optimization task definition is stored as well in the CAE file, so everything together in one final database. The optimization one, as I mentioned before, it's possible to run it on the local machine with a lot of new optimization monitoring capabilities, so you can have a look already during the run to the design responses, what happens to my objective, is it increasing, is it decreasing, and it's a pretty nice feature. But on the other hand, it also enables for access to the command line, so you can run your So you can author your optimization within Abacus CAE and afterwards run it via command line on a separate machine or an HPC environment. Also, the post-processing has been integrated in Abacus CAE, so we can have a look at the optimized design within the interface. We can look at the optimization progress, and what is pretty nice is we can also have a look at all the relevant FEA results which are stored in the ODB file. So we really have one ODB file in the end which gathers together all the results of the whole optimization progress, and yeah, that's pretty comfortable to post-process the optimization results. To have a short look and to get an impression what Abacus CAE is capable of, so that's a short video of post-processing capabilities. At that point we're looking at the material okay, that was too fast, and now we are looking at the stresses, for example, of this control arm. So it's really straightforward. If you're used to the post-processing of Abacus CAE, it's really the same for Tosca, only you're able now to look at the whole optimization progress, and based on the optimized geometry or optimized structure, you can have a look as well on stresses and displacements already within the interface, so you don't have to recalculate anything, it's all in. So, as we introduced a new optimization module within Abacus CAE, by the way, the optimization module is part of every Abacus CAE with the latest Abacus release. So now if you're installing Abacus CAE, it has always in the background already a Tosca structure. So you only need to, let's say like that, the Abacus CAE is already configured for Tosca use. So the only thing what you have to make sure is that you're running on extended tokens, and then you directly can start with your existing Abacus installation to go to optimization with Tosca. And we also like to present all the other major enhancements of this release for the other graphical user interfaces.
So the other graphical user interfaces were available already with the Tosca, but we have also made some improvements there. Let's start with the Tosca ANSA environment. This interface is based on the ANSA technology. It is a subset of ANSA, but it contains everything that you need to author optimization task, to run the optimization, and to post-process. So generally, since ANSA is also open and has interface to different FE solver, we are also supporting here the optimizations which are running with the Abacus, ANSYS, and MSc Nastran. So it means you can take your FE solver and just link it, and you can build on it your optimization task. You use the FE model interactively. You can visualize it and use it to select groups and coordinate systems and other items that you require for your optimization without changing the FE model, but all this definition will be then considered in your task optimization definition. You have automatic consistency check, and after you have run your optimization, you can perform an automatic validation run. This is based on the ANSA technology for remeshing the set and defining the loads and the boundary conditions so that afterwards you can run a validation on the optimized structure. You have also the Tosca Structure view integrated, so you would visualize, for example, the material distribution directly. And now with the new version, It supports all features of the Tosca Structure 801, including the beat and the shape when you optimize also on the damage values. So the new within this version of Toscan's environment is the integration of the new sizing module, as I already told you. So here you have, with the same logic as a new task, available the complete sizing tree where you have all the features there to define with the same logical way. So when you're familiar with the Toscan's environment and with the topology optimizations, it's really straightforward to define your sizing optimizations. The terms are the same. Another add-on is the morphing, which Miha already presented to you. It's this time lined under the shape tasks, because the way you define morphing is very similar and is based on the shape definitions, optimization for shape, so you have it available there. About the ANSYS workbench, the extension for ANSYS, for the ANSYS users, you have the possibility to author optimization task using interface to it. So here you can author topology tasks within your familiar environment. You have here the ANSYS workbench logic also integrated. Everything is available under the tree structure. You can post-process, also including a semi-automatic validation runs, and get the validation results afterwards. So the new thing with respect to the previous version is really this validation section, which is much more improved, because now you are able to get your model data, like materials and groups that were predefined for loads and for boundary conditions. Now with the very less effort, you can, after the job and optimization is done, to again apply the loads and the boundary conditions and run a validation. A new feature is the visualization of planes that are typically used for symmetries and for casting restrictions. This is also very important because it's a visual check of how correct you are defining your tasks. And with this we can close up the interface section.
Yes, but what we really see, we have only presented the major enhancements for the graphical user interfaces. So we will have put a lot of effort also to enhance all the other existing user interfaces. So as we already mentioned before, we are an open solution, and we will still be an open solution, supporting also, besides Abacus, also MSc Nastran and ANSYS. We will also really still focus on making development on the existing user interfaces. So it's really not the purpose to substitute all the other interfaces with the new optimization module within Abacus CAE. So it's really maybe the best solution for Abacus users, but ANSA or Tosca ANSA environment still have a place for a lot of our customers, and we know that, and we will definitely keep this this strategy. So of course there are a lot of other enhancements. For that, please have a look at the release documents provided with SC Tosca installation. Some general words about the Tosca Structure 8.0 release. The interfaces supported, so the SE solver interfaces with this version are the Abacus standard 6.13. So we are supporting Abacus simulations up to 6.13. The same ANSYS we're supporting up to 14.0. 14.5.7. If you plan to use nonlinear sensitivity optimizations, you at least need ANSYS 14. And if you're using the Tosca extension for ANSYS Workbench to integrate the topology optimization in the Workbench environment, you have to use ANSYS 14.5 or 14.5.7. So far we do not support ANSYS 15 with our ANSYS extension, and so please make sure that you have the right ANSYS, correct ANSYS versions if you try to plan, or if you plan to use ANSYS Workbench together with Tosca. And on the other hand, we're using MSC Nastran, or we're supporting MSC Nastran up to version 2013. And at this point, since Tosca Structure 8.0, we're not able to support any more NX Nastran solvers. This support has been stopped with Tosca Structure 8.0. One other remark, as we're talking about Abacus Standard 6.13 as an FE solver, the optimization module has been released in this enhanced way with Abacus release 6.13 AP2. So all the enhancements to the Abacus CAE interface have been or are part of the Abacus release 6.13 AP2, which was released end of February.